Hello everyone, I'm Mecca Emispina, Group 7 from STEM 11A. So now I am here with my team to tackle about what is implicit differentiation. We have this learning objective. First is we need to define what is implicit differentiation, and second is solve problems including implicit differentiation.
So as what Micah said previously, the first learning objective is to define implicit differentiation. So basically, implicit differentiation is a technique in calculus used to find derivatives when a function is not explicitly solved for one variable. So instead of isolating y, we differentiate both sides of the equation with respect to x, treating y as a function of x and applying the chain rule.
Now we will move on to our 5 examples. So our first example of implicit differentiations, number 1, x cubed plus y cubed equals 36. So let us find the derivative of each term with respect to x. So the derivative of x cubed will be 3x squared plus the derivative of y cubed will be 3y squared equals to 0, since the derivative of a constant is equal to 0. And as you notice that the exponent when finding the derivative of each term will be subtracted to 1, that's why 3x squared is there. Let us now proceed to rewrite 3x squared plus 3y squared multiplied by dy over dx equals to 0. So since dy over dx is equal to y prime. And as we proceed again, we will rewrite 3y squared times dy over dx. And let us transpose 3x squared to the right, and it will become negative 3x squared. So in cancelling, we need to divide both sides with 3y squared. So now we will cancel 3y squared and 3, and let us not forget the exponent. Now we are done in cancelling. The final answer will be dy over dx is equals to negative x over y.
And now let's proceed to our second example, which is x squared plus 2xy plus y squared is equals to 5. The first step would be to find the derivative of this one, x squared, which would become 2x, and then separate this one, which then would become 2x times y. And then find the derivative of this one also, which then also becomes 2y. And this one would become 0 because any derivative of a constant is equals to 0. And then now let's proceed to the next step. So we copy this one, 2x, and then find the derivative of this one, which is 2, and then copy this one, y, plus find the derivative of y, which is equals to 1, and then copy this one, this 2x, and then this, and because this is a y value, this should be, and needed to be multiplied by dy and dx over dx. Then proceed to this one. This is also a y value, so this should also need to be multiplied by dy dx. Dy and dx. Copy this one. So we need to isolate the dy and dx. So to do that, we need to transpose these two terms, this 2x and 2y. So this would become 2x, and then we multiply this one, 2x times dy over dx, and then plus 2y, and multiply by dy and over dx also. And this would become negative 2x and also negative 2y. And because they are all divisible to 2, we need to divide them to 2. cancel this down. This one, this one, and this one. And we would be left with x times dy over dx plus y multiplied by dy over dx is equal to negative x and negative y. And then let's proceed to factor dy, dx and y. To factor them down, we need to divide both sides, which is dy dx x plus y is equals to negative 1 x. So to factor this out, we would put here x plus y goes over this one, x plus y. So cancel this one, cancel this one, cancel this one, cancel this one. So we would be left with dy over dx is equals to negative 1. So this is our answer. That's all.
Plus y squared. So the first thing that we will need to do is square all these terms to cancel out the radical sign. This. So let's rewrite this into 36 squared is equal to, let's put a parenthesis, square root of x squared plus y squared, close parenthesis, raised to the power of 2. After it, let's rewrite this without the radical signs since we cancel this out. So it will become 36 squared is equal to x squared plus y squared times dy over dx. Let's remember that dy over dx is equal to y prime. That's why dy over dx is beside to y squared. So let's get the derivative of each term. The 36 squared will become 0 because any derivative of a constant is equal to 0. So 0 is equal to the derivative of x squared is equal to 2x plus the derivative of y squared is equal to 2y times dy over dx. And then let's isolate dy over dx. It means that we need to separate the 2y to 2x. So let's transpose 2x to the left side and it will become negative 2x is equal to 2y times dy over dx. So to cancel out the 2y, let's divide both sides by 2y. So I write here 2y divided by 2y here. So let's cancel out 2 and 2, and here let's cancel out 2y and 2y. So the answer will become negative x over y is equal to dy over dx. So this is the final answer from this equation. So I hope you learned from this example of implicit differentiation. For our fourth example, we have tangent xy is equal to 7. To differentiate this function, we're gonna have to apply the rule of trigonometric differentiation. So to find the derivative of a tangent, it is equal to square the variable multiplied by the derivative of the variable, which is x. So we're gonna have to substitute. So we have fx squared xy multiplied by its derivative, which is 1, the product rule. So we have the derivative of x, and then we're gonna have to keep y, plus we're gonna keep x, and the derivative of y is equal to the derivative of a constant is always 0. So we're gonna multiply the y values with dy over dx. That would be 7 squared xy times y 1y plus x times y dy over dx is equal to 0. Then we're going
to distribute second xy to this function. That would be y second squared xy plus x second squared xy. So we're gonna distribute second xy to y plus x dy over dx. That would be y second squared xy plus x dy over dx second squared xy. Then we're gonna divide both. We're gonna isolate dy over dx. So that means we're gonna transpose y second squared xy to the other side. That would be x dy over dx second squared xy is equal to transpose negative y second squared xy. So to isolate dy over dx, I'm going to divide both sides by x second squared xy. And that would be, we're going to divide x second squared xy. This side to x second squared xy. So we're going to cancel out this one, and this one. So what's left here is actually our answer. That's dy over dx is equal to negative y